So 4-6 part 2, it's just a continuation of yesterday. So everything we did Friday was true, everything was useful. Today I've got a different way to do this, possibly for some problems that you might like better, you might not. Let's see how it goes. But A, anybody have a thought on the word that would go into the blank? If we're talking about increase. Increase has always meant to add. Okay, so if you see a story that's talking about increases, what we're going to look to do is add 100 onto the percentage that's increased, because full price, original price, means you're paying 100% of the price. If we're going to have an increase to that, you're going to be paying more than 100% of the price. So increase problems, we're going to look to add 100 to the percentage that I'm giving you. So second blank, decrease, stands to reason, would involve you having to subtract. So if you have a sale, that's a decrease, you're going to subtract. If you have to pay sales tax, you're going to get an increase, that's going to be some kind of an add. So this strategy is only going to work on problems where we're trying to figure out a new amount that's caused by a change. So Friday formula, what was the Friday formula? Anybody do enough homework over the weekend to have that sink into your brain? Or you have enough memories from Friday to have that still rattling around in there?
Would you put the change out on the left? Or like the new, or like put one number on the left?
Something like that, yeah.
Like the X, like equals, and then you put the...
Yeah, it wasn't, where the X was kind of a mystery. A fraction, I'll take that. I'm liking that. So fraction is true. There was a fraction involved in Friday's lesson. Anybody remember what was where in the fraction?
The X is in the bottom?
Maybe, maybe not. It would depend on what you did or didn't know. We had X's here, X's there, and X's there on Friday in different problems.
The change.
Change, where did the change go?
On the top.
Top. This was the amount of change you had. That's true.
Original.
Original was the bottom. That's true. And we did that math to figure out the percentage of change. In this, the new price never appeared. You're looking for the laptop. You just grab. Yep. The password's AB12. Very secure password. There's a sticker on there that tells you what the password is anyway. The new price appeared on here nowhere. So if your goal is to find the new price, we worked through some problems Friday that did that. The worksheet you did over the weekend, in theory, for homework, did that. But if you're looking to just jump straight to the new price, this might be a quicker way to do it. Maybe you like this better, we'll find out. But if the goal is to find the new amount that's caused by these percentage of changes, if it's an increase problem, we'll look to add. If it's a decrease problem, we'll look to subtract. And then the deal is, if you take the original price times the percentage that we created, which we still want to make a decimal. How do we take percentages, make them decimals? Two spots to the left. We'll want to take the original price times the percentage we created that's made into a decimal. That's going to make the new price. So let's dive in and practice, hopefully clarifies what we just said there. So we have a $500 price that's like the original price. There's a 40% decrease. So decrease problems, we just decided we were gonna subtract. take 100 always, because that's just the basic foundation of percentages. All percentages are counted out of 100. So we'll take 100 minus 40 is 60. 60% make it a decimal would be 0.6. So if we take the original price, 500, times the 0.6, that's going to get you the new price. There's no x, there's no equation, there's no opposites, there's no solving. Just take the 500 times 0.6 and math it out. What do you think?
$300.
300 is true. Anybody need a run back on one? So 2, we're increasing. So increasing instead means to add. We're always going to use 100. So take 100 plus 7, and we're thinking about 107% in our mind. So to make some math problem here, we'd go 39 times. What's 107% if you make 107% into a decimal?
I want that geometry photo.
Sure. 107% making it a decimal.
1.07.
1.07. So we just need to go 39 times 1.07. You here for Head Start too? And here's a break for your lucky day. This is a homework where I throw calculators in play. So if you have a calculator handy, go ahead and knock it out. If you don't have a calculator handy, I'll throw you on. Anybody want a calculator? Trust your hands?
Maybe.
Maybe. Anybody else calculator usage? Sorry, they're all free to me. These are all just left behind calculators. So if we smash them, what do I care? So we're just going 39 times 1.07.
$41.73.
$41.73 is the truth. 3, on sale means increase or decrease. Decrease, so we're gonna always gonna subtract with 100. So 100 minus makes 80. Percentages will always make a decimal. So 80% makes into 0.8 or 0.80, whichever one you like. Take 0.80 times 70. Push a few buttons. Out comes $56. I would encourage you always in the story prep questions to kind of think along. If it's $70 and it's on sale and you're paying $56, that feels about right. It feels like a sale you could get. If it came out $5.60, that wouldn't feel right. You probably pushed a button wrong, or moved a decimal wrong, or something. If it came out $560, that's way wrong. Like you don't understand sales at all. You definitely hit some kind of button or did something wrong on that. 4, we're paying tax on a $90 item. So even before we start, what might you guess once you paid tax on your $90 item? How much money is this going to cost you?
$92.
Yeah, like 90 something dollars, something in that range. Maybe even 100 wouldn't be a terrible guess. But yeah, something in like the 90 to 100 range somewhere. So tax, that's an increase or a decrease?
Increase.
That's an increase. So we're gonna add on to 100. So we get 107. Second time in the last couple minutes, we got 107%. We want to turn 107% into decimal, makes it 1.07. 1.07 times
90.
90. Take the original price always times the percentage number that we make a decimal. So we're hoping for something like in the 90s.
96.3.
$96.30. 5, let's make a guess before we start. So we're getting a raise, we're making $18,000. What do you think your new salary is going to be after you got your raise? $100,000? Nah, that's crazy. 17,000? No, why is that crazy? Yeah, we should be getting more money, not less. Somebody just shoot a guess out there. You're not going to be right. Just shoot a guess.
19,000.
So like 19,000, something like that. So add or subtract? Add who and who? 103. So 103%, make it as always in the other problems into a decimal, which is 1.03. And do what with the 1.03? Multiply by that 18,000. So 18,000 times 1.03.
$18,540.
$18,540. A little bit of a bump. Not quite the 19 we predicted, but like that feels like the right kind of a number. 6, we're going to the bank. We threw in $500. We get 3% interest. We go check back on it a year later. What are you thinking?
Decrease.
100 plus 3.
We're going to add, yeah, let's make a guess before we even do the math. How much money would you expect to go back and get from the bank?
Like 580.
Yeah, like 5 something. 500 something dollars. So yeah, we're going to add. Add gets us up to 103. Make it a decimal. 1.03 times 500.
15 or 515.
515 bucks. The questions tonight, we're going to go to the book for the homework. And I'll let you use calculators because the numbers are kind of hard to manipulate without it. We're working today, let's see, I think it's 9 to 24, but I'll do a couple for you for free. I was 9 to 27, but I'm going to do a couple more for free with you in just a second. Question about the basic setup of this. Add or subtract. Add if it's an increase. Subtract if it's a decrease. And then multiply. Multiply your percentage number by the original price. That should shoot you the new price. You could also use this trick if you're trying to get the original price and you needed the new price. So if we just did this whole paper by multiplying to make the new price, what could you do if they gave you the new price? So multiplying let us create the new price. What if we already needed the new price and we wanted to work back to the old price? What could you do using algebra methodology? No. Do the opposite. So if we just spent the last 10 minutes multiplying, you'd look to divide. So if you're trying to make the new price, you can multiply using this scheme. If you're trying to unmake the new price to figure out the old price, you could divide using this same sort of trick. If you don't like the trick, use this. This was valid on Friday. It's still valid today. If doing this thing confused you, then just keep doing what you were doing Friday. But if you felt like this is a quicker way to do Friday, which I think it is, then do this. But if you don't agree with me, do this. Doesn't really matter to me. All of these things will lead you to the same sort of answer. Let's look at 158 in the book, and I'll do a couple more problems for free here for you. So again, this whole paper was set up. They gave you an old price, and you're trying to figure out a new price. That's what the last 10 minutes of practice from the notes was doing. On 158, number 9, is that what number 9 is doing? Are they giving you an old thing and wanting you to do a new thing?
Yes.
Yes. So let's just do what we've been doing on the sheet. So for number 9, your first choice is increase or decrease?
Increase.
Increase. So we're gonna
Add.
add who and who?
115.
115, which gets you 115. Make all the percentages into
Decimal.
decimals, which would be
1.15.
1.15. And do what with that?
Multiply by 19.
Multiply by $19,500. Did we lose anybody in jumping through those handful of hoops? Somebody push some buttons, tell me what you think.
$22,425.
It is $22,425. That is number 9. Homework for free. Question about 9. Somebody do 10. Is that what 10 is doing? Are they giving you an old price and wanting you to predict something new? Yes, so just keep doing what we've been doing. Increase or decrease? Decrease. Decline means decrease. So we're gonna subtract who and who? 100 minus 12 and a half. Or 12.5 if that makes you feel better. So 100 minus 12.5?
87.5.
87.5. We don't let the percentages stand forever. We make them into decimals, which would be 0.875. And then multiply that by 48. And out shoots 42. Question about 9, 10. From 11 to whatever, I'll just sort of like leave you on your own, because from 11 to a while, those are more like what we were doing last time. So don't on 11 try to keep doing what we were doing today, because it isn't that. Okay, we're going to have to use our skills from Friday and the way we did Friday, because the whole foundation of this trick today is knowing the percentage. And 11, you're trying to figure out the percentage. So the only way you can figure out the percentage is work back through that Friday thing to do what we were doing on the previous lesson. But 11 to 24, it's going to be a mixed up bunch of some stuff doing today's tricks, some stuff doing the Friday tricks. Again, the today trick works if you know the old, if you know the percentage, if you're trying to get the new. That's what today was about. So let's look down to 25. Does the today trick work for 25? No. Why not? We're looking for the percent. The trick can only work if we know the percent, and we're looking for the percent. So 25, we have to go back to this. We don't know the percentage, so if you want to fill something here, since we don't know it, you could put
X.
an X. So X equals, in that paragraph, what's the amount of change? Or what's the original, or what? What do we know? What do we not know?
140 is the change.
For 25?
It's a decrease.
Okay, it is a decrease, that's true. Do we know an old price? Do we know a new price? Do we know a change? Like, what do we know?
We could do it's now worth 8,990.
Okay, does the now price go in here ever?
No.
No. So the 89.90 we're just gonna have to set aside for a second. How about the 1850?
That's the change.
That's the change. If it depreciated by, that's just a fancy word that means changed by in a way that it went down. Depreciation means it changed, it got to be less in value. If you know anything about cars, you would know that the moment you drove a car off the lot, it's worth less money. Like, as soon as you buy a car and put a mile on it, it's worth less money than it was. Cars just they go down in value unless something really strange happens in the economy, like in the COVID days, temporarily car prices went up. That was a little bonkers, but almost the price of cars almost always is like headed down. But anyway, 1850 is the amount of change. We don't know the original amount, but you can figure it out. If the price of the car went down 1850, it's today worth $89.90. Original price of that car, we can figure it out. What would you do math-wise to figure out the original price of that car? We'd have to add our way back. The old price used to be more. It went down. So we're going to have to think algebra opposites a little bit to solve that mystery. Since they subtracted to take it down, we're going to have to add to figure out what this car used to be worth. So $89.90 adds the $18.50.
10,840.
Yeah, we're in the 10,000s. Okay, and that number that we just said, that's going on the bottom of that formula. The 1850 is going on the top of the formula. The x is already alone, so we don't have any more opposites to do. We just have to do math. What do we have to do to get this figured out?
Averages.
Well, we're going to use a calculator if you want to.
Divide.
So we're going to just divide. We're going to take the amount of change, which was who?
1850.
1850 gets punched first. Hit the divide by button. And then we're going to do the 10,000 number that hopefully you jotted down whenever somebody said that a second ago. That's going to probably fill your entire screen. Decimal, what shows up to fill your screen?
17
17, keep talking.
06642.
Okay, that's good enough, but it's going to fill your whole screen. We don't want decimal answers, we want what answers? Percents. How do we make decimals back to percent? Right, twice. So I'm going to go 17 point, and then I'm going to round correctly in this first position. Stay at 0, bump up to 1. Bump up to 1. Because if we're 5 or more, we bounce it up. So I'd say 17.1% is what I'm hunting there on number 25. $26. What's the 110? Old, new, change. Change. So I wouldn't try to use the shortcut thing we did today to start the period because the change wasn't involved in any of the math that we did. It was like new price, old price sort of stuff. So for 26, the shortcut thing isn't going to work out for us. We're going to have to work through this. Where do we put that change in the formula?
Top of the fraction.
That's the top of the fraction. So 1.10 is up there. 20% is in that paragraph. Where's the 20%? Any percent go?
To the left.
To the left. So 20% make it
0.20.
0.20 or 0.2 if you prefer. So for now, this just must be
X.
X. And we had a discussion Friday about X on the bottom that came up for the first time in your algebra life this year. And I gave you a trick for that. Anybody memory of the trick if the X is on the bottom?
Isn't it like the same thing as putting 0.20x? Like putting
Yeah.
the X to the left?
So the X is kind of like going to join the 0.20, which will in the long run make the 0.20.
20x?
Well, we still have an algebra step to do. You just drop it in.
Divide,
Divide. So basically the X and the 0.20 would just
switch.
like switch spots. So we need to punch some buttons here. 1.10 divided by 0.20. And what shows up?
550.
550. That might be the answer. That might not be the answer. It depends on what they asked you for. The X is on the bottom, and that represents the 550 is the original price of this item, whatever this item was. A record. The old days and the new days, because records are back. But 550 is the original price of the record, because that's what the formula can give us from Friday. Did they ask you for the original price?
No, current
No,
price.
current price. Did the price go up or down?
Down.
Down. So if it was 550 and it went down, how much did it go down?
20%.
Yeah, or
$1.
$1.10. So it was 550, it went down to $1.10. What's your new price that you're gonna pay?
440.
It is gonna be $4.40. Something about 26. 27 says 20 cents. Something about gas here. Is 20 cents the old price, the new price, or the change?
The change.
It is the change. So in our equation, where does the change go?
In the top.
Change goes on the top. So we got 20 cents for the top. It says 26%. So 26% goes
On the right.
on the left. What would we make 26% into?
The decimal.
A decimal, 0.26. So for now, just to fill, this would have to be
X.
X. Second problem in a row, you got an X on the bottom. We don't really like that, but we talked about this Friday and again 60 seconds ago. How do we solve when there's an X on the bottom? Just do a little switchy. So in terms of button pushing on the calculator, you're gonna need to go 20 divided by 0.26, and out comes 76.9 cents. And then maybe that's the answer, but maybe it isn't, because we're gonna have to read this question. What does the bottom of that formula represent?
The original?
The original price. Did they ask you for the original price of gas, or did they ask you for the, like today, newer price of gas? They want the newer price of gas. So how did the gas change in this story from the 76-cent basis? Increased by how much?
20.
Increased by how many? It was 76, it went up how much?
20 cents.
20 cents. So it was 76 cents, it went up 20 cents. So today it must cost adding or subtracting? Adding. So it was 76 cents, we're up 20 more cents.
86.
96.9 cents would be your gas price. And honest to goodness, that used to be the price of gas, like in the 90s-ish. Gas was usually under $1. Good old days. It's not true anymore. We're like $3.50 and stuff now. I got it for $3 1/4. It made me happy the other day. I was almost under $3 for once. Anybody want me to run back what was going on those? So if I could summarize this, if you're looking for one thing that will always work, this will always work. The Friday lesson will always work. If you're looking for a quicker but less confusing way to do it, what will sometimes work is this trick today, but the trick today I can only guarantee you if they give you the old price and they give you a percentage. I will guarantee you this multiplying trick from the paper would work. If we wanted to extend the paper, if they gave you the new price and a percentage, you could divide to like undo the problems and do the opposite of what my shortcut sheet was doing. But any problem where you're getting the percentage, you're gonna have to work through this. There's no other way to do that. Any problem where you're getting the change, you might have to work through that to get the change. Question about what's up with today's life? Okay, so the homework's for you to fill in the gaps. I did the beginning 9 and 10. I did the end 25 to 27, but your job is now the middle. So we're going to work from 11 to 24 on page 8. And again, feel free to use calculators to your heart's content because I think you'll need it. Question there?
Yes, sir.
Sure. I'm going to do real quick number 30 as well. I have on my notes, do this if there's time, do number 30. And someday this factors in to be like an extra credit problem, but it's not going to be part of your homework. So if we try to work number 30, it says they have 24 options of eyeshadow. Counting up eyeshadow choices. That's like your new amount. That's 20% more than there used to be. And they want to know how many did they used to have.
I'll probably stay in the exam period.
Works for me. So if we go to work the formula for this, what did they tell us that we can put in this formula if 24 is the new amount of stuff and 20% is the percentage?
24 is amount change.
It is not.
4.8
Say again?
4.8 would be the 20%.
Nope.
Point 0.2,
0.2 we're going to use, I agree. Where's that going to go?
the percent.
The percent change. So they told us a 20% change, that's going to be a 0.20 or a 0.2. They did not tell you the amount of change. They did not tell you the original amount. You don't know either of those things. What you know is that the new thing is 24. And the old thing, we don't really know. They can't be an X and a Y because we don't have the algebra knowledge to do that. That's like an algebra 2 move to start doing two variables in the same problem. So we have to somehow be clever. These both somehow involve X's, but they're not both X's. If I put them both to be X's, it makes it look like those two things are the same, and they are not. Okay, somehow the 24 needs to play in here.
Is it 24 minus X?
Yes, one of those needs to be the X, the other is 24 minus X. And it doesn't maybe matter which way we go, but I have it on my paper as that. One of them is X, the other is 24 minus the other. If we changed by X, and it's now 24, it used to be 24 minus X because there was an increase, so we have to subtract our way back. Solving this, what would we have to do if this came up there?
Divide.
Subtract.
It is dividing.
And subtract. Add.
Multiply.
Multiply. Since X is dividing this, if you want to do an opposite, you'd have to multiply. For 0.2 to multiply all of that, how would you show 0.2 multiplies all of that?
Parentheses.
Parentheses. And then I'll just leave you off for that. If you want extra credit someday, that problem will be back. But we'd have to do like a distributing problem, and then you'd have to do some other stuff. Answer would end up being 20 if you want to try to finish that and see if the algebra takes you to the right spot. 20 is going to be the answer, and it's just a total coincidence that 20 was the percentage. That's just luck. But it needed to be less than 24 because 24 was up from where it used to be. So 23, 22, 21, 20, 19, 18, something like that needed to be the answer. It just so happened to be 20. I'll stop talking about new. Anybody from the worksheet that we had due today but didn't really have time to look at too extensively, did anybody have anything on that you were stuck on, and we'll talk our way out of that? If you didn't do it, then do it. We could talk tomorrow about two different assignments, but Anybody have something from homework that you got stuck on from worksheet from Friday for maneuvering this formula? Okay, why don't we shut that down?